All right. Happy Wednesday. We're going to coast on into part 2 of our similar shapes lesson. So at the top of your next blank page, go ahead and title it Similar Shapes Part 2. All right. So I hope you got your detective gear ready again. We're going to try to figure out what the missing measures are, or either angles or sides. Do some more practice with that. This time, we're going to change it up and do some rectangles. All right, so let's draw a small rectangle. And then we're going to draw a bigger rectangle. So the rec center has a volleyball court, and that's how big the volleyball court is. It's 9 meters by 18 meters. They also have a pool. This is the size of the pool. It's 50 meters, and we don't know this side length over here. That's why I'm going to put X. X represents what we don't know. This is what we need to find out. So, just like we've been doing, we are going, we first need to verify, are these rectangles similar in shape? Okay. Well, yes, they are. They are similar in shape. It would tell me that in my word problem if I had a word problem, but I'll tell you right now, they are similar. So, now we're going to draw our ratio proportion boxes. 2 ratios. And we're going to also highlight the sides that are similar. In a rectangle, you have length and you have width. It doesn't matter which one you call which. Some people might think this is the length. Some people might think this is the length. It doesn't matter. Okay? You have a longer side and a shorter side. A longer side and a shorter side. So what we got to do is we got to compare what we know with what we don't know. So let's go ahead and set up what we do know. We do know that the side that's 18 meters over here on the volleyball, this is the volleyball, is on the pool, it's 50 meters. That's the proportion there. 18 to 50. Okay? That's the ratio. So we can compare the other 2 sides in the other proportion. So we have the volleyballs on top here, the volleyball measurements on top here. So we have to put the other volleyball measurement here, 9 meters. And then we're looking to find what this is. So this got to go on the bottom, X. And it matches up with the pool. So we have volleyball on top, pool on the bottom. All we're going to do here is cross multiply, and divide. You always cross multiply with what you have, the numbers you do have, and then divide by the third number. Okay? So we're going to say step 1 is 50 meters times 9 meters. Well, 5 times 9 is 45. Add your 0 because it's 50. That's 450 meters. All right. Then we are going to divide by 18 meters. So step 2 is divide 450 meters divided by 18 meters. And that's going to give us the missing link right here. So you could go over here and set it up. 450 divided by 18. Pause it right now. I want you to do that math, because you need to know how to do that math. And when you have the answer, join me back here, and we'll go from there. Okay, so if you did your long division correctly, you would know that this 450 divided by 18 is 25. So that means that x equals 25 meters. This is 25 meters. That's the missing link of we didn't have that measurement for the pool. And the way we could figure that out is because we know these two are similar. We had these two to compare to, and then we had this one to compare to also. So those three things, those three parts, help us to set up proportions so we can cross multiply and divide. So it doesn't just have to be with triangles, it can also be with rectangles. Okay? Ooh, let's do another example. This one is kind of like a real life scenario. There is a person. Yay, here's my person. I'm not a great artist. I can't even draw very good stick figures. And there is a flagpole. We'll make this a Texas flag. Okay. Just easier to draw. So we gotta find the height. We're gonna use the height of the person, which I'm gonna tell you is 5 feet. And this is the person's shadow. It's 4 feet wide, the shadow, and we're gonna make a little dotted line here to make a triangle. Okay, so now we have two parts of a triangle. You don't need to know this part of the triangle, this measurement. It's not important here today because we have enough other information here. But what we're going to try to find is the height of the flagpole. Find height of the flagpole. That's what we're trying to do here. What's the height of the flagpole? We're going to try to figure out h, which is h. Okay. Well, we know that the shadow that the flagpole casts, this is its shadow, is 16 feet. And if these are similar, like the sun is the same, shining down, the sun is shining down on both of these things at the same time, the same direction, and we're going to say these are similar. So now it's just like we have two triangles. See the triangle here and the triangle here. So I'm going to highlight our sides that are the same. That side's equal to, or similar to that side, not equal, similar. And that side is equal to that. Okay. So now, do we have enough information here to set up proportions to solve for h? Yes. Let's do what we know here with the shadows. Okay. So let's do the person on top and the flagpole on the bottom. Those are person is going to be on the top row and the flagpole is going to be on the bottom. The measurements of the person is going to be on the top and the similar measurements of the flagpole is on the bottom. So the person, we know he is 5 foot tall. We know the we don't have the flagpole's height. Whoops. We said the person was going to be on top. Can't mix the person and the flagpole. It's not the same. Okay. So 5 foot, and then his shadow is 4 foot. Okay. So now on the bottom is where we're going to have the flagpole. The flagpole is, we don't know the height of the flagpole, but we do know the length of the shadow. It's 16 feet. So now I can cross multiply and divide. I can do 5 times 16, and that's going to be 80. And then I can do 80 divided by 4, which equals 20. So now we have our missing link. The H is 20 feet. The height of the flagpole was 20 feet tall. Do you see how we got that just by setting up proportions? Okay. Okay, so let's do one more here. We're going to do a garden. 2 gardens. So they're going to be rectangles in size. One is bigger than the other. And we have 5 foot by 7 foot. And then over here we have 10 foot. And we want to know X. Okay, so we have 5 and 7, 10 and X. So let's set up our proportions. So we have 5 and 10, which are the same side of the similar shapes, 2 gardens. We have garden number 1 and garden number 2. So we're going to put number 1s on the top and number 2s on the bottom, measurements. So we have 5 foot and 7 foot. Okay, so 5 foot, 7 foot. One's the length, one's the width. So now we have to do the same for garden number 2, which is going to include our missing link. We do know that the comparable side to 5 foot is 10 foot, and we're just trying to find this. So we can cross multiply, then divide. 10 times 7 is 70. 70 divided by 5 is what? 14. So X is 14 feet. The width of this garden is 14 feet. And you probably could have just seen this and said, oh, 5, it doubles, so this has got to double too. But I wanted to make sure you know how to set these proportions up, because your math is not always going to be that friendly. All right? All right, have a good night.